Okay, let's do another problem that has the acid plus an ionic base, which we know creates a water and a salt. Okay, so I'm looking here, and the reason I know it is that is in hydrogen here. This is my acid. It has hydroxide here. I know this is my ionic base. Sorry, having trouble talking. So what do we know it creates? It always creates H2O plus a salt. Okay, the hydroxide and the hydrogen make the water. So we have left magnesium and PO4. So over here, I'm going to write magnesium, which has a charge of 2 positive. If you look at your periodic table, and then PO4, sorry, I never leave myself enough room, that has a charge of 3 negative. Okay, now let's look at that. We've written a formula, and is that balanced? As you can tell, it's not. Okay, and so we find, to remember, we cross them over. We have to have 3 magnesiums and 2 PO4s. Okay, so now we have our formula, but we have to balance it. Okay, and just like we talked about earlier, here we have 3 hydrogens that want to give 1 by 1 to make waters. This can make 3 waters, okay? But we have over here the hydroxides. There are 2 of those, so therefore it can make 2. Well, if you just did 2, then there's a hydrogen left. You can't do 3 because you only have 2. You find the least common multiple, okay? So together, to use up all that they have, they're going to make how many waters? They're going to make 6. Okay, so we're going to put a 6 here. Okay, so to make 6, though, we're going to have more hydrogens. So we'd have to have 2 of the H3PO4s, giving us 6 hydrogens there. Okay, and then over here, we're going to have 6 of this. Okay, so we'd have to have 3. Okay, so now we're going to have 6 oxygens and 6 hydrogens there. Okay, so if you look at this, it is all balanced out because you balance this correctly. There are 3 Mg's. Okay, so this is balanced just like it is.